And it's recording. Now, for those who weren't here last week, 1C was to do with, let's see if you guys remember. So I'm going to do a bit of a recap over here. Let's recap. Exercise 1C. What was 1C about? Can I please have, who was here last week? I think, Kyle, you were here last week, weren't you? What was 1C about? No, we didn't do decimals. Bo. Beautiful. LCM and HCFs. Okay, that was the main essence of 1C. And I also gave you a little bit on the back of those notes, a big chart of, starting with P. What did I also cover? Can I please have Colleen?
Not sure.
Not sure. Something that starts with P. Leon? Not sure? Sully? Not sure? Bo? Oh, yes. Actually, you reminded me there is also that too. I forgot about that. There was squares and cubes. That's true. So hence square roots and cube roots. Very good, bro. I forgot about that one. Good call. You're on fire today. Really? Prime numbers. Prime numbers was the last part of the notes there. But the main thing was lowest common multiple and highest common factor. Okay, that was the main thing from exercise 1C. So for those who weren't here for that session, there's a video up there for it. But these are the two main areas. Today's lesson is an extension of LCM and HCF. Is to help you do LCM and HCF on big numbers. So if you look at your note sheet, if you flip over to the next page, can you see the numbers down here? I'm going to teach you a technique that even if I gave it into the hundreds, you should be able to find me lowest common multiple, highest common factor of 63 and 27, but also in the hundreds, much easier. Okay, so I'm going to teach you a technique. Now, before we do that, let's go through the notes. So, going all the way back. So, here we go. Exercise 1D is about teaching you a shorter way of figuring out LCMs and HCF. That's what 1D is about. So, here we go. The fundamental theorem of arithmetic states that, so this is just pretty much anything to do with adding, subtracting, multiplying, dividing, is that every whole number that you can think of that is greater than 1 can be written as the product of prime numbers. That's why exercise 1C was key, because you needed to understand what a prime number is, right? What does product mean? Product means what, Kyle? Very good. For those who don't know, this means multiply. Okay, so the multiplication of two of prime numbers will make up every whole number that you can think of. So here's an example. The number 6 can be broken up into two numbers that multiply to give you 6. What two numbers multiply to give you 6? 2 times? 3. 2 and 3. So 2 times 3, you can see that both of these numbers are prime. If you've forgotten what the definition of primes are, it means that it only has factors of 1 and itself. That's why number 1 is not a prime, because 1 only has 1, not 1 and itself. 2 and 3, they only have factors of 1 and 2, and 1 and 3, that's why those two are prime numbers. The number 20 can also be expressed as prime numbers, because if you break it down, give me 2 numbers that multiply to give you 20. Let's go with Elizabeth. Give me 2 numbers that multiply to give you 20.
2 numbers?
Yep, any 2.
2 and 10.
2 and 10. So 2 times 10 gives you 20, but you can see that 2 here is a prime. 10 is not a prime, so if it's not a prime, it's called? Composite. Very good. So this is called a composite number. So we can break this further. Composites can be broken down into, Sully? Not 5 and 5.
Oh, you mean multiply, sorry.
2 times 5. Very good. So 2 times 5 will give you the 10. Now, what you can see here is that if I can break this down, can you see to get 10, it's a product of 2 and 5. So 2 times 5 gives you 10, but then 10 times 2 will give you 20. So if you break it all apart, it really is actually just 2 times 2 times 5. Because 2 times the 5 gives that 10, and then if you times another 2, you will get that 20. So here you can fill it in. 2 times 2 times 5, they're all prime numbers, and they are products of each other, meaning multiplying each other. So that's what the definition is saying. They're saying that every whole number you can think of can be broken down into their primes, but you multiply them together. Okay? Now, why is this special? Because this is the first technique you will need to do the shortcut method to finding LCMs, HCFs of big numbers. Okay? This is called prime factorization or factor tree, but the proper name is called prime factorization. Okay? Now, let's recap in exercise 1C. Bo said we learned squares and cubes. The reason why we had to learn that is this bit here. You got 2 times 2 times 5. What's another way of writing 2 times 2? I know the answer is 4, but I want another way of writing it. Elizabeth.
The square 2 square root 5.
Say that again.
2 square root.
Not square root, but you were correct. It was squared. Is that what you were thinking?
Yeah.
Okay, so 2 squared, when you say 2 times 2, that is the same thing as writing 2 squared. If you write, this is a recap of last week, 2 times 2 times 2 times 2, what's that the same as writing? 2 to the power of? 4, because there's 4 of them. So when you multiply the same number by itself that many times, you put a 4 up there. So if there's 4 of them, you put a 4. So when you have 2 of them, that's a 2 squared. So 2 squared, and then this one is times 5. This is key. This is what you're going to be using for that technique I'm going to show you soon. Okay, so this is called prime factor form. If you want to copy that down, write that down. This is known as the prime factor form. That's what it means. Okay, so we're going to use this technique of prime factor form to answer LCMs and HCFs of big numbers. Now, there was only one student out of my 2 classes who did this technique for one of the tests I gave to you last term. So last term, one of the mastery tasks about the laps, I think it was about the laps, how long does it take before 2 people meet? And only one person did it this way. Everyone else was using multiples. So they wrote out all the multiples. That works, but it's a very long way of getting there. Okay, so down here, if you're wondering what a divisibility test is, this is just FYI, good for you to know, some of which you already know. For example, how do you know if a number is going to be divisible by 2? So if I gave you 163, is that going to be divisible by 2? So how did you know? So you're looking at the last digit, right? So that's called a divisibility test. You're looking at the last digit. If you want to know if it's divisible by 2, if the digit is 0, 2, 4, 6, 8, which is even, then it works. Now, most students know the 2, most students know the 5, most students know the 10, and that's about it. Okay, so if I ask you, how do you know it's divisible by 10? You'll say if there's a 0. If I said, how do you know it's divisible by 5? You'd say if there's a 5 or a 0 at the end. But then the rest in between, most students don't know. And that's okay. But I thought I'd put it there so that you can see. 3, if you want to know if 3 is divisible into a number, if you add all the digits, together, and that whatever that number is, if 3 can fit into that, it's divisible. So for example, 52. Is 3 divisible? Can 3 go into 52? Now, how do you know? So you can either do your times tables, or if you add them 2 together, 5 plus 2 gives you 7. Can 3 fit in 7? No, that's what this test is talking about. Okay? Yep.
So that applies with single digits like 6 and 9. They're rule 3 here.
That's right. And so if you read 6 here, it's divisible by both 2 and 3. If it is divisible by both 2 and 3. So that's another one. But yes, you can also follow with that. All right. Now that's just a FYI. You don't need to know that, but we want to know this bit. Okay, this bit's going to be key for the next one. So here we go. This is the key definition that I want you to understand. Here's the shortcut. When you have big numbers and you want to find LCMs, HCF, this is what you have to look for. To do LCMs, you need to break them into their prime factor form. You look for the different keyword. I'm highlighting all the keywords here. LCM, you want different prime numbers, and you need to find the ones with the, fill this in, highest power. Whereas HCF, highest common factor, it's not the difference. It's not the different prime factors. It actually is the common prime numbers, and it's raised to its smallest power. Now, I did a little bit of a typo on your own sheet. You know how the example says 12 and 6? Can you change that 12 to a 16? Because mine's 16. Mine says 16. Yours should say 12. So just change that 16 to a, 12 to a 16. So here's an example, just so that you can practice. So if I asked you, what is the lowest common multiple of 16 and 6? This is what you're going to do. You're going to do what we call a prime factor tree. We're going to break it apart, so let's do 16 first. Give me two numbers that multiply to give you 16. Can I please have, yes, Leon? 2 and 8. 2 is a prime number, so you leave that there. 8 is not a prime, so you break that further. What two numbers multiply to give you 8? Let's go with, yes, Ashwin. 2 times 4, very good. 2 and 4. Now 2 is also another prime number, but 4 is not, so you break it further. Give me another two numbers that multiply to give you 4. Let's go with Mandy. 2 times 2. They're both primes now. So when you break it up into its prime factor form, this is what you can say. 16 can be made up of 2 times 2 times 2 times 2. So let's write that out. 2 times 2 times 2 times 2. Because there's 4 prime numbers there that's been multiplied. So it's 2 times 2 times 2. Now, I taught you before with powers and all that. What's another way of writing 2 times 2 times 2 times 2? Sally? Very good. This is 2 to the power of 4. I'm going to give you 30 seconds. Do the same for 6. Break it down. What is 6 in its prime factor form? Hopefully you picked up there was only 2 numbers there. Which 2 numbers?
2 and 3.
2 and 3. And conveniently, that was already a prime. So you didn't have to do much. That means 6 can be broken up into 2 times 3. Now let's read the definition. This is all you need in order to figure out LCMs and HCFs. Here we go. Just before I start, what's the power for this 2? This one is 2 to the power 4. What's the power for this 2? 1. Even though we don't write it, it's actually a 1 here. And same thing with the 3, the power must be 1. So this is how the technique works. If you want to find LCM, so I'm going to write here, LCMs, you first need to find, look at the 2 list. So this for 16, it's 2 to the power 4. For 6, it's 2 times 3. You have to look for the different primes. Now, what different primes do you have in both of the list? What different primes? What two primes can you see? 2 and 3. So you first write 2 times 3. This is how the technique works. So if it had more prime numbers, you list them all out. You got to list all the different primes that you see. So here I can see that there's a 2 and there's a 3. So list all the different primes you can see. So there's 2 and 3. But then what was the next bit? It said not only do you do different primes, but you find the one with the highest power. Now let's look at 2. They both have a 2, but which one has the highest power? Is it 2 to the 1 or 2 to the 4? 2 to the 4. So this one would be 2 to the 4. And then 3. Well, this one doesn't have a 3. The highest power for this one must be 1. So if I asked you now, what is the LCM of 16 and 6? What's the lowest common multiple? You don't have to sit there and write 16, 32, 48, and then write all the multiples of 16 until you find, and then you do 6, 12, 18, and you don't have to do that until you find the lowest common multiple. The answer is, whatever 2 to the power 4 is, times 3. Anyone know what 2 times 2 times 2 times 2 equals to? 16 times 3? 48. The lowest common multiple is 48. And I'm very certain with that. Okay, so here's my 48. If you carry it on with a 6, 6 times what will give you 48? 8. Very good. So we know that 48 will happen when you do 6 times 8. And you could have done that by listing, but this is the quicker way. So how do we do it? Use your prime factor tree, break it into prime factor form, and the key part for LCM is find all the different primes and pick the ones with the highest power. HCF is the other way. HCF was, again, so I'm going to write it again. So 16, the prime factor form was 2 to the power 4, 6 was 2 and 3. It's different. To find HCF, this is what you do. You have to pick the common primes. So looking at these two lists, what do they both have in common in terms of just the prime numbers? Don't worry about the powers. What prime numbers are in common? Just 2. So it's 2, but then you have to pick the smallest power. So it's 1. Which makes sense. 16 and 6, if I asked you what's the common factor here, if you broke down 16, 16 has 1, 2, 4, 8, and 16, whereas 6 has 1, 2, 3, and 6. Clearly, highest common factor is 2. But that means if I gave you a really big number, even in the hundreds, you can still find HCF and LCM using this technique. Feel pretty good? Have a go with this one. So flip over to the next page. I want you to try and see, using what I just taught you, can you break 63 into its prime factor form and do the same with 27? Can you break it down into its prime factor form and find LCM, HCF the way I just taught you? So you want to get into its prime factor form, yeah? So you want 63 equals what? And 27 equals what? Use the definition I just gave you. See if you can figure out what is the lowest common multiple and what is the highest common factor using the technique I just taught you. I'm going to pause the video. I'm going to give you, let's go, 5 minutes. Pause. LCM should be, what's it? The different prime factors that you can see. I can see there's a 3 and there's a 7. So 3 and 7. Highest power for 3 is 3 and the highest power for a 7 is just 1. Is that right? Highest different. Yeah, it should be 3 cubed times 7. And the highest common factor, did you get 9? So it should be common is 3, 3 squared, 9. 3 cubed is 27 times 7. What'd you guys get? What's 27 times 7? Did you all get 189 and 9? Or at least the technique? I just learned something cool from Elizabeth. You might like this technique better. It's the same idea, but less messy. If you understood this one, this technique you might like better, because you don't have to memorize highest power, lowest power. Here we go, listening. I just learnt this, so give me some time to teach this too. So, if you want to do exactly the same thing, I just learnt this. This looks so cool. So 63, 27. You do this little L shape, and then you ask yourself, what number fits into 63 and 27? Doesn't matter, but you just have to have a common number. What's the most obvious number right now? 3, because this is 6, and that's a 3, so 3 goes into 63. How many times? 21. How many 3s fit into 27? 9. And then you say, can I still break it further? What number goes into 21 and 9? 3. So then 3 goes into 21 how many times? 7. 3. Now these are primes, which is the same idea as what we were doing. We're doing the factor tree and you break it down. This is the same thing, except what's nice, is because this is a factor. You're looking for factors. So this side here, if you multiply that side 3 times 3, that will give you highest common factor. If you want lowest common multiple, you times all the different ones. So you times 1, 2, 3, 4. So you do 3 times 3 times 7 times 3, which is exactly the same as what we wrote before. That's 3 cubed times 7. So the answer should be the same as well. But it helps you remember it easier. This technique also means that your division has to be good. So if your division to be able to find a highest common factor is not good, then doing this may be a bit slower. This one could be easier if your times table is not strong. Okay, so if your times table is strong, this is probably better. Okay, this is much easier to remember. But I just learned that. That's pretty cool. Same idea, just in a different format. Easier to remember. All right, team. That is it for today. The other examples are just on common factors and factors. But that's 1D. You can work on readiness tasks. If you haven't done that, please do that. First, take out your laptop, do your readiness task. If you have done that, 1C is the next one. And we're already up to date. We've done 1C, 1D is today's lesson. Okay? Thanks, team. You've got 45 minutes of your time.